Okay, today we're looking at projectile motion. We say that a projectile motion is the motion of a body projected into the air at an angle. All right. So the part of the projection is what we call trajectory. What I mean is this: let's say we have point A and another point B. So if an object is projected from this point up towards this point B, they say that this path that was being followed or is being followed by the object is what we call trajectory. Okay, then on the trajectory, which is that path, we will have the vertical and the horizontal component of the velocity, meaning that at any point on the trajectory, we have both the vertical and the horizontal component. We call here Vx and we call here Vy. So if we come to this point of the trajectory, we also have the Vx and also the Vy. Whatever part, let's say we come to this point, we're considering here, we also have Vy and we also have Vx. So that's the horizontal and the vertical component of the velocity. So let's take an instance by looking at this diagram. We have a diagram from, let's say this is the vertical axis, all right, and we have this vertical axis to be point A. Then an object being projected from this point moves to a height where it now reach point B, all right. Then from there, it started to fall and it fell to the same ground where it was being projected. Let's say this was how it is. Then to point C. All right. So now, what we'll now do is we'll have a velocity here. This line here stands for what? Velocity. This we call here V naught. All right. It stands for what? Velocity. That is the initial velocity of that particular object that was being projected. So now, at any point here, let's say we're considering this point, we say that this point we call here Vx, which is the horizontal component of the velocity. Here is the vertical component of the projected, the velocity of the projected object. So if we're considering this part as well, let's say we're considering any of these parts, all right? So we have here to be Vx, here will also be Vx, and here is Vy. Here is Vy, Vy. This Vx and Vy stands for the final velocity of the object being projected, whereas V naught stands for the initial velocity of the object being projected. And at this particular point B, the object was at rest. Then it formed the maximum height, which is being represented by capital H. All right. So this is the maximum height. All right. That is what that place stands for. Then we have our range, which is capital R, from this point to this point. Don't worry, I'm going to explain what time of flight is all about, the maximum height and that of the range. As we go ahead, you get to know what they are all about. So we have an angle here, because initially when I explained this, the projectile motion, I told you that it always involves an angle. All right, so this is the diagram. Then taking a look at this diagram, you can now see that Vy is given to be V naught sine theta. Then Vx is also given to be V naught cos theta. Please, I know you may be confused. How am I saying that this Vy here is V naught sine theta and Vx is V naught cos theta? I'm going to explain in detail what I mean by this, so that whenever you are explaining to another person, you'll be able to digest it to the understanding of that particular person you're teaching. So what I mean is this: let's say we have a right angled triangle of this shape. All right. So we know that here is the hypotenuse side, then here is the opposite. Why is it the opposite? Because it is the side that is facing the angle, which is theta. Then here we have right angle, we call it right angle triangle. There is angle 90 degrees that is formed here. Then adjacent is the horizontal part, which is this. That is, we call it the adjacent part of this diagram. So let's call this A, all right? Call this A, B, and what? C. So there is what we call SOHCAHTOA in mathematics, all right? We call it SOHCAHTOA. SOHCAHTOA. This SOHCAHTOA in mathematics, this stands for sine, all right? Then here, this stands for what? Cosine. Then while this stands for what? Tangent. So SOHCAHTOA, it means that for the first one, which is the sine, we say that sine theta, all right, because we're considering angle theta here, is equals to what? Opposite all over what? Hypotenuse. Where is our opposite? We have opposite, all right, all over what? Hypotenuse, which is still the same thing as opposite. We presented opposite with B all over what? Hypotenuse as what? C. Then also look at the horizontal part of it, which is the cosine. Then we'll say that the cosine, which we now say is what? Cos theta, because we're representing theta here. So it's equals to what? Based on this that I've given to you, we have adjacent over hypotenuse, which means we have adjacent as adjacent all over what? Hypotenuse, which means that our adjacent here is given to be A all over hypotenuse being C. So let's apply this to know whether if it will align with what we solved here. I gave you. Then if we do the same thing, we can now see that based on this diagram, if you trace here down, all right, if you trace here down, it will form this shape, where here will now be what? Angle 90 what? Degrees. All right, I don't know if you understand what I'm saying. So here will form angle 90 degrees. It will form this shape, and this particular line here represents this, which is what we call it V naught. All right. Then this part here is what? Vx. All right. So here is going to be what? X. This is X, and this is what? Y axis. Okay. This is going to be Vs, which is what? The velocity on the horizontal part of this projection. Then here is going to be what? Vertical, which is Vy, which is the velocity on the vertical part of the projection. Now, if sine theta is opposite over hypotenuse, it means now that sine theta is now equals to opposite. Our opposite here is Vy. This is Vy. All right, all divided by our adjacent hypotenuse here is what? V naught. All right, so in that case now, it now implies that our sine theta is equals to Vy all over what? V naught, which now implies now that if you cross multiply, you are going to have that Vy is equals to what? V naught sine theta. All right. So if you do the same thing for cos theta, you have that cos is equals to what? Adjacent over hypotenuse. Our adjacent here is Vx. All right. All over our hypotenuse, which is what? V naught. So it means now that our cos theta is equals to what? Vx all over what? V naught. And by cross multiplication, you are going to have Vx is equals to what? V naught cos theta. And that's how I got that cos theta is this and cos sine theta is that. All right. That's what we need to do. Okay, there's an equation that you need to recall from equation of motion in order for you to get your time of flight, and even other questions like maximum height and that of range that you're going to solve also uh, need that equation. So can I recall an equation of motion that says V is equals to what? U plus AT. All right. This is an equation of motion, but because we are considering the action of gravity here, which means the body, when you projected the body, it was going up, and the force of gravity was acting on the body. You know, when a body goes up, it moves like this. All right. Then the action of gravity pulls it downward. And why? So we need to change this sign here. That's the reason why I'm explaining what I explained there. So here, when it was going up, this was pulling it down. So it means now that they are opposite directions. And because of that, we're going to have V equals what? U plus minus what? GT. G here means is gravitational force. So in this case now, we can have that this to be what? Vy, all right? Vy, because we are dealing with the vertical part of it, and here should now be what? V naught. So this V naught now, we are considering y as the axis. So this is the formula you are going to what? Use, all right? So, but that is not stopped there. We should now recall that we also say that but V naught y is equals to what? This, which is what? V naught sine what? Theta. So this is V naught y, because we are considering the vertical component. So if that is the case, we can now have that Vy is now equals to what? V naught sine theta minus what? GT. So this is the main equation that you are going to apply. All right, that is the equation. Okay, so that's the first thing. So now we are going to look at the time of flight before we go into the range. So time of flight. The time of flight, we say, is the time that it took the body being projected to a maximum height, which is this particular point here, B. The time it took it from point A to move to point B is what we call time of flight. All right. So how do you get this time of flight? With this equation I've already given to you, it will be easier for you to get time of flight. All right. We can now just write the equation as Vy is equals to what? V naught sine theta minus GT. All right. So now you can now recall that at the maximum height, which is this point, that the velocity was 0. The velocity I mean there is the final velocity and not the initial velocity, because this was the initial velocity when it was projected. It reached a point where Vy, which is the final velocity at this particular point, become 0. And that was the point where it was not able to move further or neither fall. So it became 0 before the action of force of gravity fall on it, and it now start to fall down to point C, which is the point of projection. All right. So if that is the case now, we can now say that this is 0. All right. If this is 0, it means this will now be taken to this side. We'll now have GT, all right, is equals to V naught sine theta. So let's divide by G, divide by what? G. So it means that G can go against G, and this is going to be what? v naught sine theta all divided by what? G. This is what we call time of flight. But we don't need to just get time of flight. We also need to have the total time of flight. What is total time of flight? The total time of flight is the time it took the body being projected to reach a maximum height and also fall back to the point of projection. All right. So it starts from here to this point, then back to the point of what? Projection. Which means that we are considering the time from here to here, then time from here to here. And time from this place to this place and from B to C is the same. So now, to get our maximum total time, we say that total time of flight is represented, total time of flight is represented with what? Capital T. All right. So, and this total time of flight is given as what? 2t, which is the time of flight itself multiplied by 2, which is now going to give us 2 multiplied by what? Time of flight being v naught sine theta all divided by what? G. So this is the formula for the total time of flight. So it's now going to give us that total time of flight is going to give us 2v naught sine theta all divided by what? G. So that is the total time of flight. This is the formula for total time of flight. We can call this equation 2 or whatever you can name it. Call this equation 2b. All right. So that's the formula for that. Okay, we have now ended proving the formula for the time of flight and that of what? Total time of flight. Now let's go into the range, which is this horizontal distance that you are seeing on the diagram here. So to get the range, we say that range, all right, being R, so we present range with what? Capital R, is the horizontal distance moved by the body being projected from the point of projection to the maximum height, then back to the point of what? Projection. So the horizontal distance covered is what we call the range. And to get the formula for us to solve this range, we need an equation of motion which says S is equal to ut plus half at squared. All right. This is an equation of motion we're going to make use of. Then, based on the projection, we can transform this equation to be Sx. Why? Is because this S here, which is the distance, is based on the horizontal distance, which represents S axis or S component, S axis. All right. So that's why I'm writing Sx here. Then now this U is the initial velocity, which I've given to you as V naught. Therefore, here should now be what? V naught what? T. And this V naught, we're considering the horizontal part, and we're not considering the vertical part. So now it's going to be V naught X, then T. Then plus, we have half at squared. This is the formula you're going to use. I know initially when I use the first equation of motion, I change this sign to minus, and here now is C plus. And someone will be asking me, why is it that you're not changing the sign? The reason is this. For the first part, we're considering the vertical component, vertical axis, where we say that the body being projected was going up and the force of gravity was acting downward, and that's what I'm changing to what? Minus. All right, because they were going in opposite direction. That is what we call counter motion. All right, so that's why we change it to minus. But in this case, we are just considering the horizontal part. There's no action of force of gravity on the body because it's just a horizontal distance. So that's why it still remain positive sign. All right, don't be confused by that. So in this case now, we cannot say that at this point C, that the acceleration was what? 0. Because the body moved from here up to this point, then the acceleration becomes 0 at this point. That's why it's now relaxed. All right. So can I say where acceleration is equals to what? 0 at what? Point C. Okay. If that is the case now, we cannot change this to be this. We will have another equation which will look like Sx equals to what? V naught x, then t. Then if this is 0, it means everything here is going to be what? 0, because of acceleration being 0. So it will remain this equation. Then we cannot see where Sx is equals to what? R, which is the what? The range that we're looking for, being this horizontal distance. And also V naught x is equal to what? V naught cos theta. All right. Then t, being the time of flight, is going to give us what? Capital T, which is the what? Total time of flight. I don't know if you understand what I'm saying. Why are we saying that the T here is capital T? It's because we do not just consider from point A to point B, but we consider from point A to point C, means the total time that was covered in order to attain point C. So that's why T become total time of flight. And if you've already done this, now you cannot see that if this is the formula now, it now means that R, all right, is going to be, which is the range, V naught is what? Have V naught cos what? Theta. All right, multiply by the time, multiply by what? Total time of flight. Our total time of flight was given to be 2 V naught sine theta divided by what? G. That's what we got as our total time of flight when we solved for time of flight. Then if you are done with that part, you can now multiply them together. And if you do that, you're going to have range to be what? This will be 2 multiplied by, this is going to give us V naught multiplied by V naught is V naught squared. To now give us V naught squared, then sine theta cos theta, or cos theta sine theta, is still the same thing. Sine theta cos what? Theta. Then divide by what? G. So that's what you're going to have. So now the next thing you need to do is, looking at this, you can see that this 2 is governing both V naught squared and also governing what? Sine theta cos theta. Then you recall from mathematics that two sine theta cos theta is equals to sine 2 theta. That's what you're going to recall from mathematics. So if you recall that, now let's substitute and see what we're going to have as the formula for solving range. So now the range, being what we're looking for, is now going to be, this will be 2 sine 2 V naught, that is V naught squared, then sine 2 theta. Okay, now so this is the formula for solving range. All right, so we can call this equation as equation 3. All right, so this is the formula we use to solve range. Now we need to get the maximum range, which we say that the maximum range is gotten at the angle 45 degrees. So maximum range, we call it R max. R max. Okay, so the maximum range R max, okay, is, or it occurs at 45 degrees, being the angle. So if that is the case now, what we need to do is to substitute the value of theta being 45 into the equation of range to get our maximum range. And if we're going to do that now, we'll have that our arrow mass is going to give us V naught, then sine theta. Sorry, this is sine 2 theta. Okay, so it's going to give us sine what? 2 theta all over what? G. So it now implies now that this 2 theta here is going, theta is going to give us multiply by 45. So if that is the case now let's multiply 45 by 2 and see what we get. So it will now be that maximum range is equal to V naught, then sine 90 degrees. So divide by what? G. You can recall that, or you say but sine 90 is equal to 1. So if we substitute 1 in place of sine 90, we're going to have our our maximum range as R max is going to give us V naught squared all over what? G. This is the answer. All right. If you substitute the value, you're going to have that. So we can call this now as equation 3b. So having gotten the time of flight and the maximum height, now we're going to look into the maximum height. All right, we have gotten the range, we have gotten the time of flight. We're going to look into the maximum height now. Okay, maximum height. For this h, that is what we use to represent maximum height. Now let's look at the definition of maximum height. We say that maximum height is the distance attained by the projected object from point A to point what? B. What I mean is this: it's the maximum distance, all right? It's the highest distance that is attained by what? The object vertically. So for you to get maximum height, we would consider the maximum vertical height attained by that particular object that is being projected. So if you look at this diagram now, you see that the maximum height attained by this object is at point B. So that's where you now get the maximum height. So the distance now should be from there to what? The horizontal part, which is what? Maximum height that you're going to get. So in this case now, if you are solving, we need to look at one equation of motion that will help us get the formula for solving the maximum height. And what is that equation of motion? The equation of motion says else, all right? Sorry. This is the equation of motion. It says V squared is equals to U squared plus 2AS, all right? This equation of motion can help us get the maximum height. Now, let's now transform it based on the projection. And this will now give us Vy squared equals to what? V naught y squared, then minus 2GS. All right? Why do I do this? So, considering the vertical axis, which is y, we represented it as what vy, because we're looking at the final velocity, because this first velocity stands for final velocity. And if you look at all this presentation here, you can see that vy stands for final velocity, and here is squared. I have to square it as well. So considering this u2, we need to look at v naught, which is this here, v naught being the initial velocity of the object that is being projected into the air. So we'll have it squared here because it's squared. So now this sign changed to minus because we are dealing with the vertical axis. No, I told you why the other one did not change was because it was on the horizontal axis. But the first one, which was the time of flight, changed to minus because we're dealing with what? The vertical axis, the time it took to reach a maximum and also come back to the horizontal. So that's why this is what going to change, because we have a force being opposed, all right? So this is going to be plus and this is minus. So it's going to be what? Minus because of that. All right. So because here we'll call it counter motion. This motion is going up, this is coming down. So they are now moving against each other. So that's why it's going to be what? Minus. And that's why I changed it to minus. And the G changed from A to G because we are considering the acceleration due to gravity in this case. Having done that, you can also recall that at maximum height, the v, which is the final velocity, is equal to 0. At maximum height, all right, which is b, all right, at b, which is maximum height, final velocity vy is equal to what? 0. So what do I mean? The velocity at this particular point is 0. Why? Is because when you project your object upward and it moves upward, it reaches a point which is the maximum height where it will not be able to move further again. At that particular point, the velocity becomes 0, and that is why it won't be able to move further. Then the force of gravity starts to act on it that makes it fall to the ground or the point of projection. Okay, so that's what you're going to do. And if you do that now, v naught becomes 0. We're going to have v, which is 0, is equal to what? V naught y squared minus 2gh. All right. So if that is the case now, it means that this is 0. Then, sorry, this is s. I want to explain something. We're considering distance, and this s here represents distance. Then the distance we're looking at here is the maximum height. So we're going to change this s here to be what? H, because we're looking at what? Maximum height in this case. So now we need to collect this, let's say, make this the solid formula, take it to the other side, and this sign changes. We're going to have 2gh is equal to v naught y then squared. Then we can now divide by this to make this the solid formula. But before we do that, we can now recall that v naught y is equal to v naught sine what? Theta.